Okay, so we look at this and it says solve the system. And most of you did substitution because it's already set up as y equals. So you put in what y equals into the original question, or into the equation number 1. So we have x squared plus, and then what y equals is negative x plus 4. But then that is squared equals 16. So I saw a lot of that. There was like an example right above it. It was just like that. And then, but if you do square something, you can't just square the numbers. You can't distribute that square. You actually have to write it twice. And then we're going to distribute. X squared minus 4x plus 16. 16. Combine your like terms. 2x squared minus 8x plus 16 equals 16. We got to there. And then we have 3 different ways that we could solve an equation that has an x squared and has that middle term x. Our 3 different methods. Somebody yell out a method for me. Quadratic formula. We could sing the song. Right? What's the second method? What's another method? Complete the square. We could do complete the square. And then our third method, if it's factorable, factoring. 2 of those methods has to say something over here in order to use it. 2 of those methods equal 0. So if you do quadratic formula or you do factoring, has to equal 0. And most people went with that method. So I'm going to subtract the 16. So it says equals 0. And we have 2x squared minus 8x, and then that 16 canceled out. And if I only have 2x squared and minus 8x, personally, I'm not going to do quadratic formula. You totally could. I'm not going to do quadratic formula because this is really easy to factor. What's our first step of factoring? Is there a greatest common factor between 2x squared and 8x? 2x. So we're going to factor out 2x. We're left with x minus 4, and it's factored. So what do we do after we factor it? So we do 2x equals 0, x minus 4 equals 0. Divide by 2, I get x is 0. Or add 4, I get x equals 4. So what we have is we have 2 x values. Our solutions are ordered pairs in which this circle and this line intersect, but they have in common. We have 2 x's. You know what that means about the number of ordered pairs I'm going to have? 2. So what we're going to do is we're going to plug in, and I'm choosing, just for fun, to plug in equation 2. It kind of looks like an easier one for me to plug in, and I'll just check in equation 1. I'm going to plug these into equation 2. So equation 2 is y equals negative x plus 4. So if I have negative 0 plus 4, I get y equals 4. Ordered pair is 0, 4. There's one of my solutions, hopefully with a check. Then I'm going to plug in x equals 4. Y equals negative 4 plus 4. So y is 0. And I get the answer of 4, 0. Hopefully that is my other solution. But I need to check my answers. Are you writing this down with me? If you got this far, great. If you didn't get this far, make sure you're writing it down too. So now I'm going to check in which equation do I have to check in? 1, because I already used 2. You could use 1 first and then do 2. It's up to you. But I have to check both of them. So I'm going to check x squared plus y squared equals 16. So I'll have 0 squared plus 4 squared equals 16. Yep, that's true. Over here I'll have 4 squared plus 0 squared equals 6. I'll wear the sleeves that right on the board. and that works. Oops. That one works as well. So since they both work, how do I write my answer?
Fancy brackets.
Fancy bracket.
Then 0, 4, 1, 0.
My answer is 2 ordered pairs. There's more than one, so we're going to fancy bracket them up. Okay? So that's what we were doing on block day, and then you did a little bit of a review on Friday over it. Now we're going to add on to this. What I want you to do next is we're going to do this graphically. In geometry, hopefully, fingers crossed, you graphed circles. But maybe not. So we're going to graph the circle. We're going to graph equation 1 and equation 2. And get my graph up here. I'll do them in 2 different colors so we can tell them apart. Let's start with the line. Number 2, the line. We have graphed these before. Oh, did everybody get graph paper? I pass it out? Okay, let's start with the line. How do we graph the line? 1 equals negative x plus 4. What do we do? Where do we begin? We're going to begin at 0, 4, the y-intercept. Where do we move from there? Negative 1, down 1 over 1, down 1 over 1. The other equation is a circle, and you guys have the formula at the top of your paper, the circle formula that says something like x squared plus y squared equals, what's the formula say? R squared. And what is R? The radius. But in the formula, it's r squared. So what we need to do is we need to figure out what our radius is, just our r by itself. What radius does the circle have? R squared is 16. Shouldn't be bigger than 16. So r by itself is 4. We're going to square root to find the radius. And then as for where the circle is located, we haven't done a whole lot of circles yet, but if there's any translations, that would be like in parentheses with the x. That would be horizontal translation. We haven't done this yet, but there would be a vertical translation if it was in parentheses with the y, which you see nothing. So because there's no translation, the center is at 0, 0. And then what's the radius? 4. So from 0, 0, go out 4, vertically and horizontally. And then the easiest way to draw this circle is what people have so many problems doing. I'm gonna lightly make a square up here, and then I'll show you how I draw my circle. I kind of have to stand right in front. I apologize. It's so hard for me to do it off to the side, so I'll move out of the way. But so I just envision this square here, and then I just kind of like round it inside the square. I don't really connect all of it. I just do like 4 separate pieces, so it doesn't look like a diamond. If you just try to connect it all, people make them look like diamonds. They're challenging to draw. The actual purple part, the circle, that's the part that I'm really looking at. And then the the question is, where do they cross? Where do they intersect? Should be our answer we already got. Where do they intersect? 0, 4, and 4, 0. And you can see they are crossing at 2 places. So number 5, example number 5, I don't want you to do all the math and solve it. I want you to just solve it by graphing. Example 5, you just solve it by graphing. Example 5, just do example 5 by graphing. Example 5, do by graphing. And don't yell at the answer when you get it, because everybody have time to figure it out for themselves. But I'm walking around if you want to see if you have the correct answer. You can place that next to you. So in the corners, you can do the corners. It's kind of like rounded towards it. And then you have rounded towards it. Try that with your other 2 corners. So it looks like a diamond. Draw using how you can roll that. Just look at going as close as you can to the corner. So it looks more like a circle around it. So if you're thinking of the answer, write it down. I can't read your mind. If you think you have the answer, write it down, but I can't read your mind. And I don't want you to say it out loud, so everybody try it. This one, the radius. Oh, you have it written down. You're not counting correctly. That's all you count on there. We're not counting too weird. All right, so I'm looking here, and equation number 1 is a circle. Question? Equation number 1 is a circle. So your graph looks circle. Yeah. Yours is wrong. You'll see why. I know what you did wrong. Somebody did that in my other class too. This is a circle. This is radius squared is 4. So what is our radius? 2. So we're going to start at our center and we're going to go 2 in every direction. And then do your best to like round it and not make it look like a diamond. Yeah, that's pretty good. And then equation 2 is a line. So we have our b value at 0, 4. And then our slope is 1. Ethan, do you know what you did now? You like square rooted it for some reason. Okay, so once I connect my line, what's my solution? Wouldn't you hate to do all that math and work through all that boiling and collecting like terms and factoring just to find out that there's no solution? It's a little bit faster to do it by graphing. Okay, go to the last page and you'll see that we are going to be solving by graphing on the calculator. Woo-hoo! If you continually are not bringing your calculator to class like you should be every single day, you're going to probably want to write down some good notes and then just do it on Desmos today, which is that online graphing calculator. You can use a laptop or you can use your phone as long as that's what I see on your phone. Otherwise, you should have out your graphing calculator. And again, if you don't have your graphing calculator, you better be writing down some good notes because you're not using Desmos on a test. Okay? So go grab a computer if you need it. Or if you're using your phone, that's fine as long as that's what's on your phone. And before we do any equations, what they have on that paper, We're going to do like a really, really, really easy one. You ready? Okay. All right. Do you know the answer? Do you know the answer? Anybody? Anybody? X equals 2. Excellent. That's algebraic. I'm going to show you how to do it graphing, and I'm choosing like a super easy one to start because you guys already know the answer. So when you see it graphically, it'll make more sense because you already knew what the answer was supposed to be originally. And I'm teaching this to you because you can use this with any equation that you have to solve for. And sometimes when you get like really difficult looking equations, like some of them on there, it's going to be faster to type it in your calculator. When would it be important to have speed? ACT. There you go. Other than that, I don't really know that it's super important to be super fast. But the ACT, if you can get more questions done in a shorter amount of time, it's going to be helpful. So that's why I'm showing you this. So what we're going to do is this x plus 3 is going to be an equation, and this 5 is going to be a separate equation. So I'm going to say on my paper, are you writing this down even though it's totally not in your notes? Maybe in that top corner where there's a big blank space. I'm going to say that y equals x plus 3, and I'm going to say that y equals 5. So what I did is I took substitution, but I kind of undid substitution. I'm giving each side of the equation its own separate graph. And when we are trying to find out where they are equal to each other, what would that look like on two separate graphs? For example, we just did a circle and a line. When we were trying to find out where they were equal to each other, what did that look like on a graph? Like the points that they have in common. So that's what we're going to look for on our graph. So you guys have your graphing calculator. Y1, we're going to type in x plus 3. Y2, we're just going to type in 5. If you have Desmos, you can do this as well. So I'm going to type in x plus 3, and I'm going to type in 5. And I hit Zoom 6 to fix my window. You don't have a Zoom 6 on Desmos, you just have to look. Are you in Desmos? D-E-S-M-O-S. D-E-S-M-O-S. Hit Zoom 6. You got a graph? Does everybody have an error on their graph, or their graph is not looking like mine, so I could come help you with it? I'll go to Desmos as well. Turn this off. What did I say? X plus 3? And y equals 5. So if you're on Desmos, really easy. All you have to do is touch where they intersect. If you're on the graphing calculator, I'm going to show you how to find the intersection, which is going to be very important on the next example that we do. But I don't know what I'm going to say. If you're only on Desmos, write down these steps. So to do this on the graphing calculator, it's not touch screen. To do this on the graphing calculator, second trait. That's where all of our fun stuff is. Second trait. And then we're going to choose intersect. We're going to find where they cross. Intersect 5. And then it's going to say first curve, because you might have more than two things graphed. It's only going to find the intersection between two. So the first two things that you hit are pretty easy. It's is this on my first line? Yes. Enter. Is this my second line? Yes. Enter. All you have to hit is enter, enter. And then it says guess. You do have to guess, and I'll show you why on the next one. And to guess, you just have to guess the x value, which we already know the answer, but pretend we didn't know. what does it approximately look like x-wise it would be at? Looks like it would be at 2, so I'm going to hit 2, enter. After you hit that, it tells you, here's the intersection, 2, 5. The exact same thing that on Desmos, I just had to click, and it tells you the same thing, 2, 5. Obviously, Desmos is way faster. You can't use the internet on tests. So, we got to know how to do it the other way as well. Now we go back to the question. What was our answer on this question? I think Morgan said it. What was our answer? The answer was x equals 2. But when I put it on the graph, why is it in order of pair? Or why is my answer not 2, 5 for this one? Can you figure out why my answer is not 2, 5 for this? Yes. How many variables are in the original question? Just x. Which is why I put the y in myself. I did that to help me graph it, but I'm not really finding y. I'm not finding that. I'm just finding what x equals. So these answers, when you're putting the y values in and graphing the different sides, you're only finding what x equals to. So the next example, we're going to follow. We're going to solve it by graphing. First thing you want to do is separate the two sides. So if I were looking for work on your paper, this is what I want to see. Y equals, or y1 equals 3x squared plus 5x minus 1. And y2 equals negative x squared plus 2x plus 1. Then you're going to use your calculator to graph that. I'm going to graph them as well, and then that way you can check your graph with mine and make sure it looks the same. Okay, so I have my graph. You can look at your graph to make sure that yours looks the same. And then we will find the answers together. Good. Good. Go back to y equals. And turn it close. You forgot your squared on negative x squared. That's why it doesn't look like a right. All right. So once you get this, now we're going to go to second trace, intersect, number 5. Second trace, intersect, and it says first curve. Am I on the first one? I should be. There's only 2. Enter. Now am I on the second one? If you're not sure, you could use your left and right arrows to move to make sure that you are on, indeed, the other graph, which I am. Then it says guess. Now there are 2. It's only going to tell me one of them at a time. So I'm always going to go with the left most intersection. So I'm trying to figure out that. Approximately what x value do you think this one is over here? Negative 1? You don't have to think that long into it. Just like, it's close to negative 1. Enter. Then it's going to tell you, nope, it's actually negative 1.18. And then it gives us a y value as well.
Why does it do that? Why does it make you guess?
So why does it make me guess? How many intersections are there? 2?
Yeah.
How does the calculator know which one you want? Like you want both, but it's only going to tell you one at a time. So how would the calculator know which one you want? You're going to tell it what number it's close to. So that's why we have to guess, so that you can get both of them. Because we'll do it again, and we'll guess close to the other one. So this one I'm going to approximate negative 1.18. And then we're going to go find the other one. And remember, we're just solving for x, because there's only x's in the equation for these. So I'll go over it again. Let's find the other intersection. We go second choice, and intersect is number 5. First curve, I'm going to use my arrow. Just make sure I'm on the blue one. Yep, I am. Second curve, and then you're going to guess close to the one on the right. So approximately what x do you want to type in? You don't even have to be that accurate. 1? Okay. And it tells me it is at 0.43. Yes, Mom.
Oh, you might just need to say, for this one, when I tried the first one,
Uh-huh.
so what I guessed and did negative 1, did my guess like it actually was instead of negative
Okay.
1.
I'll come look. All right. Now what I want you to do is try this next one, B. I want you to try B, and then I can come answer some questions while you're trying B. All right, so you have it. So that really was where it was intersecting if we typed it in wrong. Try that again. You don't have to go do both of them and see how right it is, but try just make sure you get that first one. So I have my graphs typed in. You want to check to make sure yours looks right. And if it doesn't look right, I can come around and help. How can you fix your window if you don't like your window? How can you fix it fast? Zoom? What? Zoom 6 work? So then we're going to do second choice. We're going to intersect. And first curve, second curve, I'm guessing at 0. And it tells me, yep, you're right, 0. There's only one answer for this one. It's at 0. So I'd expect on your paper you have y1 equals negative parenthesis x minus 1.5 squared plus 2.25, and y2 is 2x, x plus 1.5. That's what you have on your paper, and then you have x equals 0. All right, just try the last one. I want you to just try 8. Try 8. And then after you try 8, the assignment's in the book, and I'm going to put it up on a board. Oops. After you try number 8, that's the assignment. I'm going to stop the video now, but you guys keep working on number 8 when we go over it.